Hello everybody. For this video I'm coming to you from my garage where you can see I stocked up on toilet paper. Just making sure I don't run out. Can never have too much toilet paper. All right, here's our last law for the first lesson of this series of 4 videos. I'm going to share my screen with you and we will hit it quick. All right, so this is Law 7. This is the one that gets people all turned around and flipped upside down for good reason, because it involves moving things around to the other side of the fraction. And so basically, in just plain language, what the law says is anything with a negative exponent moves to the other side of the fraction bar and becomes positive. So if you had a to the negative n, it would become 1 over a to the negative n. The key thing that's hard for people to see sometimes is, what do you mean other side of the fraction bar when I don't see a fraction here? Well, you need to think about it the same way you would think about a whole number. That's over 1, right? And then it's not that this 1 went to the top. It's that this a to the n had to move to the denominator. Notice how the sign of the exponent became positive. And then since there wasn't anything left on the top, we know that we just have to hold that spot with a 1. So let's, again, explore the why of this. We don't want to just go on rules. We want to know why these things work. So if we step this back one more level, we would have 2 to the negative first power. And if we want to know what that equals, we could say, all right, let's just continue the pattern. And so if I do this little pattern here again, let's just be lazy and just grab this and do copy, paste, paste. There we are. What's 1 divided by 2? Well, let's change colors. It's 1/2. And so look at that. Where was the 2 to the negative first? It was in the numerator. Where did that 2 move? To the denominator. We could write that as 2 to the first right there if we wanted. Continue the pattern. What would, dang it. What would 2 to the negative second be? Well, continue this pattern. And 1/2 divided by 2, what's half of a half? Yes, that's right, smart children. That is 1/4. And if you look at that and you see what that really is, that's 1 over 2 squared. And so what happened? This negative exponent that was in the numerator moved to the denominator as a positive exponent. If you did it again, you'd get 2 to the negative third is 1/8, because half of a fourth is an 1/8. And the pattern just continues, and we're like, sweet. And we know why the law works. So we can just practice it. A to the negative third, we have to have a fraction bar now because we didn't need one here because this was in the numerator. But now this needs to go to the bottom of the fraction, the negative on the exponent, and we need to hold the spot of the numerator with a base 1. So a to the negative third becomes 1 over a to the third. All right, what happens if we start in the denominator? Well, if we think about this, we need to take, oh no, what did I do? We need to take this from the denominator. We need to place it in the numerator. We need to remove the negative, and And then if we wanted to hold the bottom spot with something, it would be a 1. And we don't have to write p to the 4th over 1. We can just write p power. Sorry about the font change there. It bothers me too. And so you would just quickly kind of skip this middle step and say, oh, this is 1 over p to the negative 4th. Must move to the numerator and become p to the 4th. All right, so what happens when you have multiple ones all trapping this up in the same problem like this? Well, I just play the keep it or move it game, right? So we look at each of these things and we say, what kind of exponent does it have? So w to the 3rd, I'm going to just keep it where it is because there's no reason to do anything. X to the negative 2nd, let's color code this. So to keep it, I know that that guy should just stay where he is. I know that this guy should move because he has a negative exponent. I know that this guy should move because he has a negative exponent. And I know that this guy should stay where he is. He has a positive exponent. So if I just follow those rules, I get this. If you notice, the w to the 3rd stayed where it was on the top. The x to the negative 2nd moved to the bottom and became x to the 2nd. P to the negative 4th moved to the top and became p to the 4th, and m to the 9th stayed where it was. Now the order of these within the numerator and denominator don't matter, so the p to the 4th could come first because multiplication, the order doesn't matter. But that would be the answer. All right, so lots of common issues come up with this. It's pretty easy first 4 little mini videos here, but there's a lot of spaces where people make mistakes on tests. Classically, a problem like this has been the most commonly missed question on the multiple choice test every year on this unit. And so what you have to do is realize what is getting the power. And so 3x squared, we say what's that equal to? Well, 3x squared is equal to 3x squared. There's nothing you can do with that. You're not squaring the 3 and the x in this one. So 3x squared is just that. In this case, because we've got parentheses, the answer is going to be 3 squared, which is 9, and x squared. And so it's really easy to get tripped up by these things, especially if we're using a 0. So if we went 5x to the 0, whoops, come over here, and we went 5x to the 0 power, this one right here is equal to 1, but this one right here is equal to 5, because only the x to the 0 power becomes 1, and then this basically is 5 times 1, which gives us 5. So boys and girls, be super careful about this. All right, another common issue is I was kind of tentative to use the word distribute when I taught you this law a couple of videos ago, but really what you're doing, it's an okay word, is you're distributing that 2 to all of the bases inside of here. And that works if you have multiplication inside of here. So this would be 3 squared x to the 6th. Sorry about my mouse handwriting, which would be 9x to the 6th. You have to look closely because you can't do that here because you don't have multiplication. Because of this plus sign right there, we know that you cannot distribute an exponent across addition like that. And so if you wanted to do this problem, the only way to do it, okay, I'm gonna get fancy. No, I'm not gonna get that fancy, is to think about this thing as double distribution, or as you guys like to say, FOIL. You have to take this entire thing and multiply it out and then go, let's multiply the 3 times the 3. Let's multiply the 3 times the x to the 3rd. Let's multiply the x to the 3rd times the 3. And let's multiply the x to the third times the x to the third. I will leave that up to you to finish because I don't need to show you that again for the 10,000th time. And then this issue, this is super important on your calculator as well. If you have your TI there, you just got to be super careful. When you enter this into your Texas Instruments calculator and many other models, you are thinking, I would like to make this be -3 times -3, and you're expecting an answer of 9, but if you type that in, your calculator is going to tell you that the answer is in fact -9. And your calculator is not broken, it is just strictly following order of operations, and it's doing the exponent first before it's thinking about any addition or subtraction operations. If you really want 9 to be your answer, you have to put the negative thing that you're squaring in parentheses. Now, let's be real about this. You shouldn't need a calculator for this problem, but if you are going to square something and it's a negative, well, we know that that's the same as just 3 squared. So most of the time when I'm squaring something on my calculator and it's negative, I just drop the negative because 3 squared is also equal to 9, and we can avoid this. Whoa, that's a good one. We can avoid this whole issue going on over here. All right, that is the final video of the first series of videos. We're not going to have this many videos every day, I promise you guys. It's going to settle down. All right, I'm going to really quickly go to, where should I go? I'm going to go to the beach, I think, and I will see you all real soon. I hope you're all doing well. Office hours, they're posted. If you need any help on any of this stuff, don't hesitate to reach out to me. I'll just be sitting like this in front of my screen waiting for you guys to log in. Bye.